Good morning. My name is Dr. Millenizer, and today we're going to talk about acceleration and force. Newton's second law describes that acceleration is proportional to the force applied and the inverse of the mass of the object. To put it into mathematical form, you're probably used to the equation force equals mass times acceleration. For our class, we're going to rearrange that as acceleration is equal to force divided by mass. To put it another way, as you increase the force on an object, it's going to start speeding up faster and faster. If you decrease the force on the object, it's going to slow down more. We call that a direct relationship. As one goes up, the other goes up. By contrast, mass, if you use the same force, it's going to cause a heavy object to move very slowly, but a small object to move very fast. We call that an indirect relationship, since as one goes down, the other goes up, or if one goes up, the other goes down. That is an inverse relationship. Now I'll give you an example problem. 1,000 newtons of force is applied to a 2-kilogram rock, about 5 pounds, or a small 1,000-kilogram car. To find the acceleration for each, we're going to take force is equal to mass times acceleration. The first step is going to be identifying the mass. Whenever you see newtons, that's a force. So newtons is the force. Whenever you see kilograms, that's a mass. And we'll have this as mass number 1, or mass of the rock. And we'll have this as mass number 2, mass of the car. So when we're solving our problems, we'll be finding acceleration. We're going to be using the 1,000 newtons of mass, and we'll be replacing the mass in the equation with either our rock or our car. So once again, we have 1,000 newtons of force, and we're going to apply it to our 2-kilogram rock. We place the mass, the kilograms in the M, and the item in newtons in the force. So again, newtons are a unit of force, and we divide by the mass, 2 kilograms. And we end up with 1,000 divided by 2. 1,000 divided by 2 is 500, so our answer is 500 meters per second squared of acceleration. That rock is going to go very quick. However, by the same token, on the second problem, our mass is 1,000 kilograms, and our force is still 1,000 newtons. We're going to replace the force with 1,000 newtons, and we're going to replace our mass with 1,000 kilograms. So here, now we're going to replace our 1,000 kilogram mass with the mass and 1,000 newtons of force, and we'll get 1,000 newtons divided by 1,000 kilograms. And that will give us 1,000 divided by 1,000 is 1 meter per second squared. Now let's do a practice problem together. What is the acceleration of a 1,000 kilogram car, which receives 5,000 newtons of acceleration? Now let's start by finding our knowns. We have a mass of 1,000 kilograms and a force of 5,000 newtons. You know it's a mass if it ends in kilograms. It's a force if it ends in newtons. So it's going to be acceleration is equal to 5,000 newtons divided by 1,000 kilograms. 5,000 divided by 1,000 is 5 meters per second squared. Let's do another one. What is the acceleration of a 2,000 kilogram truck which receives 8,000 newtons of acceleration? Our mass is 2,000 kilograms, and our force is 8,000 newtons. So again, we're going to set it up as force divided by mass, 8,000 newtons of force divided by 2,000 kilograms. 8,000 divided by 2,000 will give us an answer of 4 meters per second squared. All right, and if you have any questions, here's our emails. Have a good rest of your day. Thank you.